In this video, we're going to take a look at exam revision for gradients of a line. So we're going to take a look at some exam style questions where we're finding the gradient of a line using the graph method, like we can see on the screen here, and without a graph. So let's jump straight into it here. So what I've been given is this graph, and I want to find the gradient of the line L below. So where do we begin here? Well, for the graph method like this, all we do is we draw a right angled triangle. Now there's loads of different triangles you can draw here. It's up to you. Sometimes you might just spot a triangle straight away. Sometimes you might have to think about it. But remember, the key idea here is we draw the triangle and finish the triangle on points that have integer values. So don't pick, say, this point here, okay? Because we don't know exactly what that point is, okay? I don't know what its x coordinate is, and I don't know what its y coordinate is exactly. However, notice if I start here, we know the x coordinate and the y coordinate exact. And if I finish, say, here, again, we know the exact x coordinate and the exact y coordinate. So what I do now is I count how many I go across to form this triangle. So my triangle here is going to be like this, like so. This is a right angled triangle. And in this case, then, how many units do we go across? Well, we go 1, 2 units across. And now we check how many units we go up. And in this case, we only go up 1 unit. Okay, we've gone up 1 unit there. So for the gradient then of this line L, remember we use m here to represent the gradient. We're looking at the change in y. So the change in y, how many units we've gone up or down. So the change in y over the change in x. So how many units we've gone across. Okay. Well, in this case, the change in y is how many units we went up, which was 1. And the change in x, how many units did we go across? Well, that was 2. Okay, so we went across 2 units. We get 1 over 2. And we can't simplify this any further. Okay, so in this case, the gradient is a half. So what that's telling you is for every unit you go across, we go up half a unit. So for example, if I go across 2 units, notice we go up 1 then, because 1 is half of 2. Okay, if we was to go across 4 units, we would have gone up 2 there. Okay, so that's the idea though. So if I go across 4 units, so 1, 2, 3, 4, notice we go up 2 units, so 1, 2 there. Okay. So there we have it. So that's our gradient for the line L there. So the gradient of the line L is equal to a half. Taking a look at these two here now, where this time we've been given the points rather than the graph, and we want to find the gradient. So to find the gradient using the points like this, remember we need the formula. So m is equal to y2 minus y1 over x2 minus x1. Okay. Now, it doesn't matter whether I say this is x1, y1, or this is x1, y1. But obviously, you just need to be slightly careful then how you substitute that into your answer. I like to just work from left to right. So I'm going to pick this as x1. This is y1. So then this would be x2, and this would be y2. There won't be anything wrong with switching that around. So that would be x2, y2. That would be x1, y1. Nothing wrong with that, but obviously make sure you do the correct substitution there. So y2 minus y1. Well, y2 is 14. Minus y1, which is 0, so 14 minus 0, which will just give me 14, but we'll write it down just to make it clear there. I then got x2 minus x1, so x2 is 3, x1 is 1, so 3 minus 1. If I simplify this here, I get 14 as my numerator. As my denominator, now we're doing 3 minus 1, which is 2. So I get 14 over 2 there. So how many 2's go into 14? Well, that would be 7 there. Okay, so the gradient of the line that passes through these 2 points is 7. I'm just going to repeat that for this question here now. So again, do pause the video if you feel confident enough. Do practice these questions we work through. But if you're not too confident yet, let's take a look together. So again, we're just using this exact same formula here. So m is equal to y2 minus y1 over x2 minus x1. And this is a good habit I would get into of making sure that you denote the formula every time. You aren't given this formula, so it's something that you have to memorize. So again, let's just pick x1, y1, x2, y2. And again, I'm just working from left to right. So this is going to be x1. It's going to be y1. And this will be x2. And this will be y2. Okay. So in that case, then y2 is 1 minus 5. So we've got to be very careful here. So I'm doing 1 minus 5. This is going to be over x2, which is 0, minus x1, which is minus 3. I do 0 minus 3. A common mistake here is to kind of drop one of the minuses and just take that as, for example, 1 minus 5 over 0 minus 3. careful, that's not correct, okay? Because what happens now is when I simplify here, 1 minus 5, that's the same as 1 plus 5, okay? Same with the denominator here, this becomes addition, so I get 0 plus 3. Well, 1 plus 5 is 6, and then 0 plus 3 would give me 3. So I get 6 over 3, so how many 3's go into 6? Well, that would give me 2 there. So the gradient of the line that passes through these 2 points here is equal to 2. Taking a look at another example now where we're looking at the graph method here for finding the gradient of a line. Now, the first thing you should notice here is that our graph is going downwards. Okay, so what we'd expect here is we get a negative gradient. And again, I just need to draw a triangle here. Again, there's loads of different triangles you can draw. So straight away, what I spot here is to draw my triangle going from here to here, and then from here to here. Okay, so I just join this up just so you can see the triangle. It's going to look something like this. Okay. Again, all I do now is I check how many units we've gone across. So in this case, we've gone 2 units to the left. Now, don't worry about the fact that we're going to the left here. Or technically, I should say we're going to the right because it's a negative gradient. We're going 1, 2 units across. That's a difference of 2 there, or the change in x is 2. And this case now, when we're going down, in terms of the change in y here, we take this as negative. Okay, so I've gone down 1, 2 units. I'm going to take that as minus 2. Okay, so for the gradient m, remember, that's the change in y. I'm going to use delta here to represent the change. So change in y over the change in x. So this is just the Greek letter delta. Don't worry about it too much if you haven't seen that. I don't want to confuse you. I'm just using it as shorthand to represent change. So the change in y, well, that would be how many we've gone down, which in this case is 2. So we take that as negative. Okay, because this is a negative gradient. I get minus 2 over the change in x, which is 2 here. So minus 2 over 2. And in this case, I'm going to get minus 1 when we simplify that. Okay. And there we have it. So do think about these straight lines here and what you would expect. Obviously, if I got a positive gradient here, we'd know we'd done something wrong. We should get a negative gradient there. So the gradient of the line L here is equal to minus 1. And then finishing with 2 more questions here where it's getting a little bit more complicated now, because this time we're involving a little bit of algebra. So for the first one here, I've got 2 points. A is the point 1, 3, and B is the point x, 8. Okay. Now we're told that the gradient of AB is 5, and I just want to find the value of this x coordinate here. So what I'm going to do is use the fact that we have 2 points here. So we know the gradient is equal to y2 minus y1 over x2 minus x1. Okay. And I need to pick my x1, y1, x2, y2. So I pick this as x1, y1, and this is x2 and y2. Okay, and again, all I'm going to do now is substitute these in. But what we do know is that this gradient here is 5. So when I substitute these in, so y2 is 8. So we do 8 minus y1 here, which is 3. So 8 minus 3. All over x2, which is x here. We don't know what that is. We're going to work that out in a moment. So x minus x1, which is 1. So x minus 1. We know this is the gradient, and we know that it's equal to 5. Okay, the gradient of AB is 5. We set this equal to 5. And what I'm going to do here now is just solve. Okay, so I'm going to multiply through by x minus 1. So therefore, what I get here is 8 minus 3 is equal to 5 lots of x minus 1 there. Okay, expand this bracket here. So I get 5x minus 5 is equal to 8 minus 3, which is 5. So that's equal to 5 there. And all I need to do now is solve this linear equation here. Okay, I'm going to add 5 to both sides. I get 5x is equal to 10. And then finally, if we want x here, all we need to do is divide by this coefficient here in front. So we divide by this 5 in front. And in that case, we get x is equal to 10 over 5, giving me 2 there. Okay. And in that case, then B has the point or the coordinates of 2, 8 there. Okay, so little x is equal to 2. That would be our solution to that one. And if we take a look at the very last question here, again, pretty much identical. The only difference here now is working out the y coordinate of the first point. Again, we know the gradient, that's equal to -2, so I'm just going to set it up in exactly the same way. So what I'll do is I'll just clear the screen just so we've got enough room here. So I'll just write down the formula again for the gradient. M is equal to y2 minus y1 over x2 minus x1. Again, just assign x1, y1, x2, y2. So x1, y1, that'll be x2 and y2. So in this case, y2 minus y1, so that's going to be a minus y. So I'm going to do a for y2 minus y1, which is y. We get 8 minus y all over x2 minus x1. So x2 is 10, x1 is 5, so I get 10 minus 5 there. And we know this gradient here is equal to -2. So all of this is equal to -2 there. Okay. So what I need to do now is just simplify this and solve for y. So if we take this down here, so the numerator is 8 minus y. I can't simplify that. So I'm just going to get 8 minus y there as the numerator. For the denominator now, I've got 10 minus 5. So 10 minus 5 would give me 5. That's all over 5. And we know all of this is equal to -2. This is the gradient of AB. Okay, so that's equal to -2. So what I'm going to do now is get rid of this denominator here. So to do that, we're going to times both sides by +5. Well, if I do that here, what I'm going to get then is 8 minus y on the left-hand side is equal to 5 times -2, which would give me -10. Okay, so we get 8 minus y is equal to -10. And all I need to do now to solve, all I need to do now is to find the value of y, and to do that, we're going to solve here for y. So the way I like to do this is make y positive, so I'm going to add y to both sides. I'm going to add y to both sides, and I'm also going to add this -10 here. I'm going to get rid of this -10, and to do that, we add 10 to both sides. So what I'm going to get then, if we do that up here, is y is equal to a plus 10, so a plus 10 there, giving me 18. Okay, and there we have it. That's the value of y. So y here is equal to 18. And there we have it. So that's our solution. And that brings us to the end of this video on exam revision for finding the gradient of a line.